Hi everyone. In today's lesson, we're going to be looking at factoring quadratic expressions. And what do we mean by factoring? We are talking about rewriting an expression as the product of its factors. So for example, if we have x squared minus x minus 12, we could factor that, two numbers that multiply to negative 12 and give us negative 1, and that would be x minus 4 and x plus 3. So that's what we mean by factoring. Sometimes we need to pull out the GCF, the greatest common factor, a common factor of the terms of the expression. And if you look at the example I have here, the common factor for each term is 2x. And that's another way we can factor. When factoring expressions, we first want to check to see if there's a factor common to all parts. If so, factor that out first. So always, always, always factor out the GCF first, and then go from there. That will make your life much easier. So you can see in example A, we have a GCF of 4, so we're going to pull that out. And then we would continue factoring if we can. X squared plus 5x minus 3 is not factorable, so we're done with letter A. Letter B, the GCF is 7. We'll pull that out. P squared plus 3 cannot be factored any further, so we're done with letter B. And the GCF for part C is 2w. Now, just a little tip, if you're not sure if you factored it out correctly, just go back and multiply, what you pulled out to each part in the term. So 2w times 2w gives me 4w squared. And 2w times 1 gives me 2w. So I know I did that correctly. All right, and part C is now fully factored. All right, so moving on. A quadratic trinomial is an expression in the form ax squared plus bx plus c. That's standard form of a quadratic. And you can factor many quadratic trinomials into two binomial factors by finding the product AC that has a sum of A and B. So we want, and looking at this example here, we want two numbers that multiply to negative 5 but add to negative 4. So let's do number 2 together. So two numbers that multiply to 8 and then add to 6. Okay, so that would be 4 and 2. Done. All right, what I would suggest at this point is pausing the video and then come back and check your work. All right, so now we're going to move on to a slightly different level of factoring where we have a leading coefficient that is other than 1. And there are many different ways to approach this. Some people like factor by grouping. Some people like what's called the rainbow method. I, for fun, refer to it as the Kung Fu trick. I have a link right here where you can watch the Kung Fu trick demonstrated. But let's talk through the example that I have here. The first thing that you want to do is you want to multiply these two values, have a rainbow here. 6 times negative 4, that's negative 24. And then you rewrite the expression. You lose that coefficient of the first term, and you use the value you got when you created the rainbow, which was negative 24. Then you factor just like normal. So this is back to easy factoring, two numbers that multiply to negative 24 but add to negative 5. And then at that point is where you apply the trick. You're going to take that value of 6 and you're going to divide it into the values you got when you did the factoring. The next step is to be very careful. Once you have it written with the value of 6 divided in, you want to make sure you simplify before you proceed. All right. And you get x minus 4/3 and x plus 1/2. And then you take the denominator and you move it in front of the x. And you get 3x minus 4 and 2x plus 1. So in this case, those would be the factors. And the solutions are here. All right, so let's do one together. I'm just going to write this guy over here to make it give myself a little room. So we have 3x squared minus 16x plus 5. And we're going to do the rainbow, and we're going to get 15. Then we get x squared minus 16x plus 15. Okay, now we're going to factor that like we normally would. So two numbers that multiply to positive 15 but add to negative 16. And now we're going to apply the trick. So the original coefficient was 3. We're going to divide by 3. The next step we're going to do is simplify that. Now, 15 divided by 3 is 5. We can't simplify 1/3 any further, so we're simply going to just bring that 3 in front. So our final answer is x minus 5 and 3x minus 1. Now, those are the factors. If we were asked to solve, then we would keep going and we would say that x is 5 and x is equal to 1/3. But for now, we're just practicing factoring, getting the factors. All right, again, I would suggest at this point you pause the video and then come back and see how you did with the rest of the problems on this page. Okay, so we have our last page here, factoring special quadratic expressions. Often you're going to see difference of two squares, and if you can recognize that, it's just going to save you a lot of time. So what it means is that you have a perfect square subtracting a perfect square. So we have an example here, x squared minus 4 equals x minus 2 times x plus 2. So if you can recognize that you have two perfect squares, you can use this method every time. This guy would be x minus 8, x plus 8. This one, number 18, is a little bit sneakier. First, I'm going to rewrite this. So I'm going to rewrite this as that makes it really easy to see what the perfect squares are now. 2x squared in parentheses is the same as 4x squared. So my factors would be 2x minus 7, 2x plus 7. I'll do the same thing with number 19. So my factors are 3x minus 1, 3x plus 1. And lastly, we're going to rewrite 16x squared as 4x squared. So that becomes 4x minus 2, 4x plus 2. All right, so that's all I have for this lesson, everyone. Hope you have a great day.